You paste a prompt into an AI, wait a few seconds, and suddenly you have a working prototype running on your own computer. It feels powerful. But when you try to take that local demo and add user authentication, connect a database, and ship it to a live domain for actual users, progress stops. The code conflicts pile up and the prototype stalls. Local demos collapse under the weight of real-world requirements. Deployed software relies on secure connections, structured data flow, and scalable infrastructure. We are going to bypass the typical 6-month learning curve for programming syntax, and we are going to avoid the restrictive ceilings of no-code platforms. By the end of this workflow, you will deploy a live, full-stack AI agent to your own custom domain. To do this, you need a specific set of tools. First, an agent-first IDE, like Antigravity or Cursor. These are code editors designed to let AI write and execute code autonomously. You will also need access to Gemini 3.0 Pro and Claude OS 4.6, along with a standard production-ready codebase template. Building modern software requires a new approach. You no longer need to memorize thousands of lines of syntax. Success now depends entirely on how well you organize the architecture and how clearly you instruct your AI tools. Step 1 is upgrading your workspace. A single chat window is fine for answering questions, but building software requires parallel orchestration. You need multiple agents working on different parts of the application at the same time. We handle this by configuring a manager view inside the IDE. This gives you a high-level dashboard where you act as the orchestrator, watching multiple Gemini agents draft code, test new features, and install dependencies simultaneously. To guide these agents effectively, we use an architectural model called the digital restaurant. The digital restaurant breaks down like this. The front-end landing page is the dining room. Your back-end, Fast API and Firebase, acts as the kitchen. LangChain frameworks are your chefs. Separating these layers lets chefs process heavy data in the kitchen without freezing the front-end interface. When beginners mix their interface code directly with their AI logic, the entire application freezes the moment a user asks a complex question. Modular separation prevents that collapse from happening. Now that the architecture is set, we can generate the actual application. You provide plain English instructions, and the AI translates that intent into a verifiable codebase. We use Claude Opus 4.6 for this step because of its ability to generate artifacts. Artifacts are dedicated windows that display verifiable development plans and exact code diffs, rather than making you read through raw text logs. You review the plan on the left and watch the landing page update on the right. At this stage, many people try to prompt the AI to write custom user authentication and API connections from scratch. This leads to days of debugging security flaws and broken login screens. Instead, use battle-tested production templates. You provide the AI with a pre-built boilerplate, including Fast API for server logic, Firebase for user databases, and Flutter for the visual interface. By cloning a template where the login screens and database rules are already written, the foundational walls of your application snap into place in minutes. Relying on boilerplate for the basic infrastructure frees you up entirely. You can spend 100% of your energy designing the custom AI logic that actually makes your product valuable. With the building constructed, we wire up the intelligence using LangChain and LangGraph. These are libraries that allow us to string multiple AI language models together to handle complex, multi-step workflows. To give the agents autonomy, we implement the React framework. React stands for Reasoning and Acting. It forces the language model to first think about a problem step by step, and then take a concrete action, like searching a database or executing a script to solve it. A standard chatbot is stateless. It answers your prompt, forgets the conversation, and waits for the next command. An agent operating system retains context, references past interactions, and independently decides what tool to use next. We achieve this by configuring memory logging. Every time the agent takes an action, the result is saved back into the database. The agent constantly reads this growing log, allowing its knowledge to compound over time. Persistent memory and autonomous action separate isolated lab demos from highly functional products that grow more use more with every interaction. The final step is moving your application from your local computer to the cloud, where anyone in the world can access it. Instead of opening the terminal and manually configuring servers yourself, you instruct Gemini 3.0 Pro to take control. Gemini drives the terminal directly, installs the necessary server packages, and executes the deployment commands to platforms like Hostinger or Microsoft Azure.
Deployment always exposes bugs.
When an error stops the server from launching, you don't need to manually hunt through the configuration files to find the missing comma. You copy the raw error logs from the terminal and feed them directly back to Claude Opus 4.6. The model evaluates the failure, designs a system fix, and provides a patched code diff to apply. In this workflow, the AI operates as a dedicated DevOps engineer, handling the testing, debugging, and cloud configuration, so you can focus on the final product. By following this sequence, orchestrating agents, utilizing boilerplate, wiring persistent memory, and deploying autonomously, you end up with a live URL running on your own custom domain. You transition from a text-heavy terminal demo that only works on your laptop to a fully authenticated web application ready for public traffic. This stack produces real results. Students using this exact blueprint have shipped a psychology tool for ADHD management, an entire marketing operating system governed by 9 distinct agents, and a weather intelligence platform that automates data exports directly into an Azure data lake. You have the tools. Open your AI IDE, load the production template, assign your agents their tasks, and start building your storefront. The ability to build complex, production-ready software no longer requires years of computer science. It requires a clear idea and the spoken intent to execute it.